everybody, this is the final section for circles, and it's going to talk about inscribed angles. We mentioned them briefly in the beginning of the chapter, and now we're going to look at them more formally in this section. Just a reminder, an inscribed angle is an angle whose vertex is on the circle, and the sides of the angle are chords in the circle. The arc that is inscribed with the angle, or that makes up the, the two endpoints of the angle, it closes it, is called the intercepted arc. To find the measure of an inscribed angle, it's always going to be half the measure of its intercepted arc. So if we were looking on this picture here, and I knew that arc AC was, we'll say 80 degrees, that means angle B would be half of 80 and it would be 40 degrees. And again, I just made up that just to show you how to find the angle measure. All right, so here we have angle ABD, and we want to find the measure of angle ABD, which is right here. It intercepts with arc AD, which is 124 degrees, and we know the measure of each inscribed angle is half the measure of the intercepted arc. So if I take 124 and divide it by 2, we end up with 62 degrees, and that's the measure of angle ABD. All right, so here, this one's kind of easy and nice. They give us the information that we need. We want to find, we know the measure of the angle. We know the measure of angle EHG is 90 degrees. So the measure of angle EHG is 90 degrees. And we want to find the measure of arc EFG. Well, if the angle is 90 degrees, remember the intercepted arc is twice the measure of the angle. So if I take 90 times it by 2, I'm going to get 180 degrees, and that will be the measure of the arc, because the arc is twice the number of degrees of the angle, or the angle is half the number of degrees of the arc. All right, so here we are going to find the measures of the inscribed angles, and the first angle they want us to find is angle T. So for these, it's helpful sometimes to trace them. So here's angle T, and then they also want us to find the measure of angle R, and angle R is right here. Now, one thing to notice about these two angles, even though they don't have the same vertex, they don't share a common side, they do both intercept the same arc. They intercept arc SQ. So that means angles T and R are going to have the same measure. The intercepted arc is 66 degrees. The angles will be half of that. So if I take 66 and divide it by 2, I'm going to end up with 33 degrees, and that will be the measure for both angles T and R. All right, so here we are finding the measure of angles, or the values of variables A and B. So A is right here and B is here. So A is an intercepted arc, and I'm going to say A is going to go from P to T, so we need to know that. Now, what we can see from there is I can trace an angle that intercepts with PT, and that angle is 60 degrees. So remember, the angle is half the measure of the intercepted arc. So if I take 60 and I times that by 2, I'm going to get 120 degrees, which is going to be the value of A. Next, if we look at B right here, it intercepts this angle. Let me do a little erasing so we can kind of see better. All right, so angle B is right here. And it intercepts this whole arc, which now that we know A is 120, we can add 120 and 130. We get 150. So that is our intercepted arc for angle B. We need to divide that by 2, and when we do that, we should end up with 75 degrees. So B is 75 degrees. All right, here are just a few corollaries that go with the inscribed angle theorem. The first corollary says that two inscribed angles that intercept the same arc are congruent. And we looked at that when we looked at the last example or a couple examples ago. An angle inscribed in a semicircle is a right angle. And the opposite angles of a quadrilateral inscribed in a circle are supplementary. And those are three corollaries to our inscribed angle theorem. All right, so here we need to find the measure of each numbered angle. So my first angle here is number is 1. And if I trace the angle there, it's right here. So what I need is to find the measure of this intercepted arc. And if we look, this right here is a diameter because it goes all the way across the circle through the center. So that means that this intercepted arc right here is a semicircle or half a circle. It equals 180 degrees. So that means that right here, angle 1 is going to be 90 degrees because that is half of 180 degrees. Okay, next we have angle 2 here, and it intercepts this arc right here. And I also know that if I look, we have another inscribed angle that intercepts the same arc. Both of them intercept this arc right here. Now I don't know the measure of this arc, but I do know this angle right here is 38 degrees, and that's always half your intercepted arc. So if I were to take 38 and times it by 2, that's going to give me 76 degrees. Now, we don't really technically need to know that. I need to know the measure of angle 2 because they intercept the same place. Angle 2 is also going to be 38 degrees. All right, so we talked about angles formed with secants and tangents outside the circle or chords inside the circle. Now we're going to look at a chord and a tangent, so part inside, part outside. The formula to find the measure of an angle formed by a tangent and a chord is going to be the same as your inscribed angles. The measure of the angle is always going to be half the measure of the intercepted arc. So it'll be just like your inscribed angles. Okay, so the last thing we're going to do here is we are going to find the measure of angle 1. We want to know the measure of angle 1. I know that SR is tangent to the circle at Q, and I know the measure of arc PMQ, which is PMQ is right here, is 212 degrees. So I can use that, and I can do this a couple different ways. I could find the measure of angle 2, and then I have my linear pair, which is what I think I'm going to do. So if the intercepted arc for the measure of angle 2 is 212, if I divide 212 by 2, the measure of angle 2 is going to be 106. So that means that 1 and 2, again, they form that linear pair. So angle 1, if I take 180, subtract 106, I am going to end up with, that's a 1 there, never mind, just ignore that, 74 degrees. So angle 1 is 74 degrees.